Hey guys, welcome back to Introduction to Computer Networks at NTU. Yeah, good to see you guys. Okay, so I'm yet to figure out what your IDs are on YouTube chat, even though that I can probably figure out from the names you've provided me with. Okay, good. Hi to you all. So let's go to the announcement. So we see the lecture link as usual in the Google Meet session for the office hour tomorrow and for this week. Yeah. We do have the first programming assignment due, but no worries, the first programming assignment is more for you to be able to try and see if you can log on to the PA workstation and try the basic Unix commands you are going to need in the future. All right. And then we have 3 quizzes likely due, and again on Saturday this week. Something that's a little bit new. There's a Google spreadsheet, okay, that you can check every now and then throughout the semester and see if you get the credits you deserve. All right. So this is the Google spreadsheet that you guys can, with the link, you'll be able to access. But try not to share that with other people. And just something that you know, please allow us a little bit time to grade. And it also takes a bit time to record the progress as well. Because what I feel more important is to communicate what's wrong, right, in case you points are deducted. Okay, so it will take us a little bit time to grade and record the progress. But in the meantime, if you find any of the recorded grades, there are any bugs, any issues, let us know. All right. And if you scroll up a little bit on the announcement channel, you will see that Henderson has kindly generated a summary of last week. And reminded you guys what might be a little bit traumatic for you guys coming ahead, which is PA1. And I see some of you are already asking questions about PA1, particularly how do I access the workstation? And no worries, I think those are important questions and I'll spend a little bit of time to take you through. Okay. And here, Henderson is really kind, reminding you guys that for these more open-ended questions, or in fact, for all the quizzes, what we are looking for is you tell what is your thinking process, why. Not just like, you type something up. That would actually help you learn. And that is, in fact, the things that we wish you learn. Not just, hey, this is the answer. If you get tested, if somebody asks you, this is what you say next time. It's less like that. Okay, it's less like that. Becoming an engineer or becoming a scientist. All right. And so that was Henderson. And Henderson has done a great job helping debugging you guys' problem at accessing the workstations. So thank you also to the students interacting with Henderson and eventually figuring things out. And it also requires a little bit of my involvement, but trust me, much of the work is done by the TA. All right. Thank you, Henderson, and thank you for participating and reporting issues. And so I think one thing that I would like to draw your attention is this question that was just raised earlier before the class starts. Excuse me, do we have the IP address of the workstation for PA1? Yeah, of course, it's a very good question and important question because you guys will need to submit PA1 by Saturday, right? So here's the answer. So the IP address of the workstation is stated in the PA1 PDF description, but also conveniently for everyone attending the lecture, it's right here, 140.112.42.221. Okay, good. And where's the PA description? Guys, go take a look at the golfer. If I scroll down the course page, you see there's this link called Golan, right? That is the programming language we'll use, and this link contains all the PA assignments. So programming assignment number 1, Unix command. This is the title of the PA. If you click in there, you will see the PDF of PA1. Okay, and of course, Polly will try to prepare you before you start working on it. Okay, and you will see the style. Of course, it will take time to read those, but to take you a sort of fast forward, all right? The assignment is finally here. So before the assignment, that's just to give you an overview of the PAs, especially for stage 1, okay? Because the first 6 PAs are related, if you recall, I think last week, the Wednesday session. So, hey, you need to get an account, which is what you are assigned to after Poly finishing grading quiz 2, right? And here you will find the IP address, and with the account, the default password. The default password is something that you receive through email, all right? If you did not receive the email, definitely let Polly and Henderson know. And with the username, password, and the IP address, you may now SSH to the PA, all right? So if you go to the PA channel, PA1 channel, you will see also more information popping up. And some of these are because TA interacting with students, and then even though they get the username, password, and they know the IP address, they have trouble SSH in because, Polly tried to add to the explanation. The PA workstation is behind a firewall. Hey, these days we need to be careful, okay, to ensure that our workstation is secure, okay, and that is for everyone's good, all right? So it allows only SSH access from within NTU, all right? But hey, you guys might be working on the assignments from home. How do you access the workstation then? Luckily, NTU has the NTU VPN service available. So all the students, all you need to do is just to request access to this NTU VPN service. And you need to, so for those who need English access, click this link. Those who are faster with the Chinese info page, click this link. And you will find out that how you apply for that service and the softwares you need to install and the configuration of the software in order for you to be on NTU via VPN. Okay, and from there, you should be able to access the workstation according to the result of debugging last night. All right, good. And again, feel free to post the questions, of course. During the lecture is also fine. But you guys might want to focus a little bit more on the lecture, which is coming up next. Yeah, the topics today. If you recall, at the end of last week, we started having this very high level overview of the internet, right? We learned already how there are these end systems, like such as Polly's desktop or your laptops, such as all these IoT devices. They can be very diverse, but they all get access on the internet. Okay, and all of us are end systems. And then there's also the core of the internet. In the core, you see a bunch of routers. Well, in fact, we don't usually see these routers. Okay. And between the end systems and the routers, or the core, between the end and the core, at edge and the core, we have the access net. But guys, beware, the access nets still come towards the edge of the internet. Okay. And then we started talking about specific ways to access the internet. So these access network technologies, we actually classify them into 3 categories. Remember, there's the residential access, the institutional access, and the wireless access. Most of all, last week we already learned about ADSL, the digital subscriber line. And the reason that it's called asymmetric digital subscriber line, ADSL, is because you learned last week the downlink bandwidth is 8 megabits per second. Uplink is only 1 megabits per second. It's obviously asymmetric, and that's why we call DSL more often ADSL. And the bandwidth is barely enough for home access, right? But luckily, it's dedicated for the whole household. Okay? Those who are looking for higher bandwidth access, hey, here's one option. It's called cable modem, which is the next access technology we'll talk about. All right. So once again, pay attention to the video. At the beginning, Polly will talk about these characteristics: bandwidth, downlink, uplink, whether we share the bandwidth or not. But in the later part, Polly will use an example and take you through, and you get to see the mechanism of how cable modem works. Okay, and behind you will see that the way we send digital data over the cable modem network is still, we try to modulate analog signals digitally. All right, good. Now guys, bear with us. This video is long, 5 minutes and 40 seconds. It's the longest so far. So let's see how you do. Okay, so cable modem. And the second access net is cable modem. A little bit similar to DSL, it's also for residential access. And unlike DSL, which is exploiting the telephone infrastructure, cable modem there uses the cable TV infrastructure. Yeah, you see, we also have lots of wires behind the walls leading to a central office, leading to the cable company. That's how we receive the TV programs. So, cable modem here, exploit that existing infrastructure. What's nice about the cable modem is this. The bandwidth available, it's also asymmetric, where you see the downstream bandwidth and the uplink bandwidth different. In cable modem, wow, lots of downstream bandwidth, 30 megabits per second, but very limited upstream bandwidth, only 2 megabits per second. If you judge based on only the amount of downlink and uplink bandwidth from cable modem and compare it to DSL, you'll see, whoa, cable modem wins, obviously. Yeah, for DSL, this is only 8, and this is only 1. But you want to be careful, though. These cable fibers attaching household to the cable company, they are shared access links. Unlike DSL, these telephone wires are dedicated access. That is saying, oftentimes a cable company will set big cables, center cables from the center office to a neighborhood. And there's going to be a splitter that splits TV programs and across hundreds and maybe thousands of households. Yeah, if you use cable modem, sending data, your data and all your neighbors' data will be multiplexed on that cable and to the central office. That cable there is not dedicated, it's shared. So even though the bandwidth is higher, but you can be competing potentially with all your neighbors. And it really depends on how many people are subscribing to the cable modem service in your neighborhood. That determines really the quality of your internet access. To illustrate, let me show you this example where we're connecting hundreds and thousands of households together through one major pipe to the cable company. And inside the cable company, you see often lots of these video servers, and stored on these video servers are the TV programs. So the cable head will stream these videos down this way. Gets splitted here, 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 here. Okay, depending on what each of the household is requesting. Okay. Occasionally also, from the household, there could be some control messages being sent, for example, to switch channels. Okay, for example, to turn the TV program off. Now, if you have the cable modem installed at home, the infrastructure is going to look a little bit more extended, but most of the extensions are inside the household, as well as in the central office of the cable company. Yeah, I know, if you look at this picture here, you see, very familiar, right? Just like DSL. If there is signal coming in, the splitter here will check. If it's TV program, it will go on this way. If it's data, internet data, it will go on this way. And the cable modem will convert it to the format that's readable from our PC, and therefore you read the message from your friend. And similarly going out the other way, right? So your message will go out from the household and through the shared pipeline to the cable company. And inside the cable company, there is this big multiplexer and modulator that's doing the right thing so that your internet data goes on to the rest of the internet. Okay? And your friend sees your message. Now, be careful here. There's only one cable here. If there are messages coming from this other household or this other household, they will all get merged onto this cable. Now, these messages coming from the household, they will share the same channel and compete for the bandwidth there, unfortunately. Another thing that you might find surprisingly similar between cable and DSL is this: how we are multiplexing the original infrastructure networks data as well as internet data. And this is how cable modem is doing it. These first few channels are video, data, and last one, control. The channel towards the left, lower frequency. The channel towards right, higher frequency. So essentially what you're seeing is that the entire frequency band allowed on a cable network are divided into some subbands. Okay, so 1 to 6 are for videos, which are the TV programs. 7A, in this example, are for the internet data. And then these control messages, such as switching to a different channel, to a different TV program, is only just one subband. Right? And so they kind of run on frequency subbands that are not overlapping, completely separated, so that they would not be interfering with each other. Okay? So that technique is formally called frequency division multiplexing. Okay? So we kind of cut the entire frequency band into non-overlapping subbands, division over frequency, hence the name. All right, so in cable modem, we get higher amount of bandwidth, but unfortunately, we're actually sharing that bandwidth with a bunch of neighbors. And how bad it is really depends on how the cable modem company connects a particular neighborhood. So Poly used to subscribe to cable modem for internet access when that was like a decade ago, but that was the beginning of cable companies helping connect users to the core. But not long, because the price is fairly low. Not long, many users or household users discover a fair price offer with higher amount of bandwidth. So that's why ADSL begins to deplete. But then when everyone joins the cable modem access network, we were competing for bandwidth. And that is why people start to turn to FTTH, fiber to the home. It's a technology that offers higher amount of bandwidth and flexible amount of bandwidth and potentially symmetric bandwidth, while the whole bandwidth you subscribe to is only limited to your household. Okay, so this is FTTH. And here you will not see Poly saying that, oh, the uplink bandwidth is this and downlink bandwidth is that, because it's all configurable. Depending on how much you can afford, you can actually purchase a package that is exactly for your need. All right. So you can actually subscribe to a symmetric plan where you have 100 megabits up low, 100 megabits down low, which is what Poly should be doing. Okay, given that I will be streaming from home this semester, and it's dedicated. All right. But in this next video, you will hear also most of the time Poly will be describing essentially how FTTH works. Okay, connecting us to the core. Fiber to the home. This is the third access net technology. Unlike the previous two, where we kind of exploit certain existing infrastructure, telephone network or cable TV network, this one here builds its own network. And because the cable are all optic fibers, so it's called a optic network. And it's essentially the internet service providers, if they want to allow users to access internet using FTTH, they will have to go out there and build these optic links into the civil infrastructure. So there are physical contact, okay, through some cables between the central office to home. And so you see in this example, it's very clean between the central office to each household, just optic cable, optic cable. The only slight complication and boxes that are a little unfamiliar to you are these. First, optical line terminal. Optical line terminal. So this is a dummy device. What it does is just to collect signal and then convert them into digital bits. Okay, so that these internet data can go on natively through the edge router and out to the internet. Now, what's a little bit more interesting is this box, the optic splitter. We've seen this term, splitter, the third time. Yeah, at the physical level, these splitters are essentially the forwarders or the switchers. Okay, so signals gets forwarded to the right destination at this point. And signal gets multiplexed also so that they can go on further upstream. Okay, so splitter plays the role of demultiplexing signals so that it reaches a particular household, or multiplexing signals so that it goes to the central office. So its role is a little bit like the routers or switches at the core of the internet. So optic splitter here is a very important device for the optical network. In this example, we see there's only one level of it. In practice, there could be multiple levels, so that you could have a regional optical splitter, and then you could have another splitter here inside the building in case there are multiple households in your building, okay, also subscribing to the optical service. Now, these splitters, depending on the mechanism that's running in it, okay, depending on the design, could work differently. Okay, so two typical architecture for these splitters are these, PON and AON. So passive optical network. What it meant is that what's being done here is very straightforward. You just have mirrors so that you can reflect signals so that they go on the right direction to the destination. There's no signal amplification. But if you use active optic network splitter, yeah, these signals get splitted and amplified before they get passed on further. That is very necessary in case there are multiple levels of splitters along the way. As a signal, as it travels longer distance, even though it's optic signal, it still decay. Okay. Now, in FTTH, yeah, the downstream or upstream bandwidth vary, but essentially the maximum capacity is much higher than the cable modem network, than the DSL network. Okay. In Taipei, very typical, you subscribe to services that's downlink 100 megabits per second, uplink 40 megabits per second. Okay. If you have special need, for example, if you are hosting web servers, then you might subscribe to 100 megabits per second downlink and 100 megabits per second uplink as well. Okay, so it can be symmetric, it can also be asymmetric in terms of the bandwidth going in different directions. So essentially much higher rates, and it really depends on how much you can afford. Right? And nowadays, these fibers can also carry telephone or television services. Okay, think about video on demand. So that is to carry TV programs through FTTH. And digital phone, okay, IP phones are one example. The trend is going towards that's just move to FTTH and then abandon the older legacy technology such as telephone, such as cable TV. So all content, including data, are transmitted over the one and only internet. One ring to rule them all.
All right. How do you like that? So internet seems to be the eventual winner of all these different telecom technologies in the old days. Now, moving on. The next okay, moving on, but before we move on, FTTH, I personally probably find the only disadvantage is just this, the dollar sign. It's costly, okay? But I guess for all modern technologies, that's the case. If you want something that performs better, you ended up paying more. All right, moving on. Next one, and we are moving from the residential access now to the institutional access.
This one is Ethernet. And Ethernet is designed such that the designer wants it to be simple. All right. The way it works is very simple. Simply, everyone sends data, and the hardware there, we call the Internet hub. When it detects there's collision, then they inform the sender, try to resend it, and that's it. And nowadays, those internet hubs are no longer hubs because we add some hardwares into it. And so that we optimize the transmission there and setting up something like a circuit dedicated for communication flows. So these days, we call those internet hubs internet switches because we are actually switching data. So by switching it, it's what it means is really, really fast, hardware fast. Okay, so this video, because it's simple, very short. The fourth network access technology is Ethernet. Now, this is something that we're very familiar with. All we need to do is to purchase one of these Ethernet switches, connecting our computer through the Ethernet cable to it, and this guy is connected to the edge router. Then data can go out and in from the internet. Such a network access is typically used in companies and universities, okay, as they have direct access to the edge router. For households, we usually don't have access directly to the ISP's edge routers. Okay, so even though you're trying to connect your end systems through Ethernet cable to a switch, but that doesn't mean your access network is that Ethernet you're using. Be careful. Now, the rate these Ethernet switch is operating goes from 10 megabits per second 10 years ago all the way to nowadays 10 gigabits per second. But I think typically people use an Ethernet switch at this speed, 1 gigabits per second. And nowadays it's actually dedicated upstream 1 gigabits per second and downstream also 1 gigabits per second. 10 gigabits per second Ethernet is a little bit limited and only those companies who are, for example, hosting a lot of data. Then they need 10 gigabits per second Ethernet, particularly video providers. All right, and lastly, the wireless access. This is the last category. You will see that Wi-Fi and the 4G, 5G cellular access we're using, they all belong in this wireless category. So this video is also relatively short, 3.5 minutes. This is the last access technology. It's called the wireless access. That's just how I refer to both of these wireless access technologies in a general term. Okay, the common characteristic is that all the devices, okay, on the same channel will share access. So the way it works is this: devices sending wireless signals. It's picked up by the wireless base station and then passed on to the edge server and then further on to the internet, and vice versa. So these base stations, in the context of Wi-Fi in particular, are also called the access points. Now a little bit more about Wi-Fi. AL2.11b or G, this is actually a pretty old standard. I'm pretty sure that all of us are using AL2.11 at least N. Okay, so that's Wi-Fi generation 4 in another way. The bandwidth with Wi-Fi generation 4 is already close to 400 megabits per second. Okay, and the frequency band is no longer just 2.4 gigahertz, but also the 5 gigahertz band. Okay, that's why when you purchase a new Wi-Fi AP, you see that, hey, a lot of times when you set it up, you see two channels, one for 2.4 gigahertz, the other for the 5 gigahertz. The next major generation is Wi-Fi 6, which operates also on both 2.4 and 5 gigahertz for backward compatibility, in case you're still running AL2.11b or G. For Wi-Fi 6, the bandwidth actually go up this high, 900 and plus megabits per second. Really nice. I think in the next generation, that's called the AL2.11ad. Yeah, for this version of Wi-Fi, it's gonna operate at this frequency band, 60 gigahertz. It's super high frequency, super high data rate. In fact, 5G is also aiming at this frequency. So the bandwidth is going to be a lot higher, but you see also that the transmission is very directional, a little bit sensitive to the antenna design. Okay, and very sensitive in case there's mobility. All right. Wi-Fi, interesting development there, AO2.11ad. The last one, okay, wide area wireless access actually meant, so 1 megabits per second, this is for 3G, okay. For 4G, we get slightly more than 1, sometimes go a few megabits per second. With 5G, you get easily tens of megabits per second and sometimes very close to 100, but only downlink. I have not yet seen any sort of measurements about 5G uplink bandwidth. It would be very interesting to know if you find any. Okay, but although these bandwidths we're talking about, downlink, uplink, it's increasingly higher and higher even for wireless access. But be very careful. As opposed to Ethernet, as opposed to optic, wireless is, after all, shared access. So these 400, 600, 900, or close to tens of megabits per second bandwidths are shared among all the users. And nowadays, we are probably connected to the network more through wireless access network, okay, than the wired one.
All right, so that was the last access network. All right, before we go over the last video to summarize everything, you see on the chat, the YouTube chat, Polly actually posted Wi-Fi 7 transmits also on 6 gigahertz frequency. So Wi-Fi 6 and Wi-Fi, I think the previous Wi-Fi transmits on 2 gigahertz frequency and 5 gigahertz frequency. In the next generation Wi-Fi, Wi-Fi 7 transmits also on 6 gigahertz. So that's even higher energy. So higher volume allowed, but significantly shorter distance. Okay. Okay, good. And something Polly posts there is also pop-up quiz. That is just to make sure that you guys are following or helping you guys following the lecture. So sometimes you guys need to be sort of motivated in order to, concentrate. So I was asking, hey, is your cellular access 4G or 5G? Hey guys, as I expected, in Taiwan, it seems that many of us stay 4G. Yeah, given the density of these cells we have, especially in central Taipei, 4G is plenty. Oh, look, Ivan was saying, actually, I just changed to 4G yesterday. Oh, you use prepay. Okay. Interesting. Okay, I think most of you 4G, right? Anyone here using 5G? Ting-Chi, both 5G and 4G. Yeah, I guess for especially students, probably 4G, because 4G is significantly cheaper. And I don't know, for some reason, 5G is substantially more expensive in Taiwan. Okay, I see someone 5G/4G as well. Are you going to talk about LTE? Well, think of LTE being 4G. No, I actually meant 4G implicitly for LTE. But no, this course is overviewing internet. The next course after this one is then can be wireless network or wireless internet. Then you get to learn about LTE. In fact, people are actually accessing internet more these days over the 4G, 5G, LTE network. So I think in Taiwan, it's very often that we just do 4G/LTE to cross-reference the cellular data access, LTE or 4G. I guess it's just how different sort of country or different region refer to that kind of internet access differently. All right, good. Very good to know. And I think I read a survey from news magazines that they also find it's interesting that 5G is here for a long time, but for some reason, the Taiwanese subscribers stay on 4G. No problem, Yasin.
Guys, if you know why, let it, share why you stay on 4G. Have you thought about going 5G? Okay, I guess, hey, this is still important. Okay, good. So next video is to summarize everything. You will see in this video that these 5 access net technologies, sometimes we do mix and match. In a particular environment, we might be using multiple of these to access the internet. And the summary video is also short, 2 minutes. To sum things up, we've talked about 5 access networks: DSL, cable modem, and the very powerful FTTH, the optical network, to allow all the data, not just text-based, but audio-video data, to traverse. And it's replacing the traditional phone network, replacing the traditional cable TV network. We also talk about Ethernet access and the very, very popular wireless access. Now, all these 5 are access network technologies. These 3 definitely use a lot more for residential access. These 2 definitely use a lot more for institutional and mobile access. But nowadays, in a household, as the demand of using internet is on the rise and there are a lot more end systems are connected to the internet at home, having just one particular access network to enable multiple machines to go online at the same time is really challenging. So we have a hybrid access network in a way. In this example I'm showing, this is a very typical home setting. Cable modem here is to access to the internet for the household entirely. But after the cable modem, we have what? An Ethernet switch here, okay, which is also called a router, which also runs the firewall functionality. This guy here would allow, for example, these PCs to connect to Ethernet cable to it. Yeah, these PCs are accessing internet using Ethernet switches. And the switch here can also connect to a Wi-Fi AP, and so that these laptops are accessing Ethernet through Wi-Fi. So in just this example, you have devices accessing the internet through different access net technologies. And be a little bit careful when I ask what is the access network for a particular computer. It can be relative, right? So this guy here is through Wi-Fi, this guy here is through Ethernet. But if I ask, how is this household accessing the internet? Yeah, the access network used by the household entirely is the cable modem. Careful, right? All these access technologies can be mixed, okay? But the real access technology used for that household to connect to the internet is the modem, okay? Good. All right, and we go on to the next topic. We just finished talking about the access net, and we talk about the access nets as a whole system. We will be talking about the cables, wired or wireless, okay, next. These are called the physical media. In this video first, only 2 minutes, we'll introduce the terminology that you will see, as well as the first type of wire. It's called twisted pair, and they're also called the cat cables. So these are the cables used by the Ethernet. And most importantly, coming up next is quiz number 4. So pay attention to this one. Here we're going to switch gear a little bit, but still about access network technologies. And so far, if you paid attention, each of these access net technologies operates on some sort of mechanism or protocols. They also operate with assumption on there's a companion physical media. This is important, just like the protocols are important to achieve a certain expected performance, typically achieving a really high bandwidth. So let's go over these physical medias that work side by side with each of these access technologies. Now first, let's define some terms. Bit. These bits are propagated between the transmitter and the receiver. And between the transmitter and the receiver, whatever the media is called a physical link. And these links can be wired. There's a special term called guided media for it. If it's wireless link, then it's unguided media, meaning that the signal might just go propagating omnidirectional everywhere. Okay. As opposed to guided media, there's usually a copper wire or an optic fiber that the signal kind of just follow and being guided to travel through the physical media. Now, there are four kinds of physical media we'll be talking about. First is twisted pair, and this is one of the commonly used cable for Ethernet. Cat5, this is very old for Ethernet. That's 10 years ago. Nowadays, I think we're still using a lot of Cat5 cables, which supports up to 100 megabits per second and might be reasonably okay for 1 gigabit Ethernet. But if you purchase a 10 gigabits per second switch for intensive use, make sure you get these cables, Cat6, particularly 6A. This will allow you to have physical transmission bandwidth up to 10 gigabits per second. Just, by the way, it doesn't make sense to buy a really high-speed switch and the cable limits the speed, okay?
All right, so we are ready for quiz 4. Good. So we were just talking about Cat 3, Cat 5, and Polly mentioned Cat 6A. You know what? Here's a table summarizing the cables we often use. I think previously we used this cable a lot, Cat 5E. So that's kind of an extended version of Cat 5, all right? And it's modulating over this bandwidth, so 100 megabits. And the more recent cable, 6A, modulates on a wider bandwidth, okay? Similarly, you see the shielding. It's actually more carefully done from older generation to the newer generation. So the older generation are just plastic wraps around the copper wires, and there are 4 pair of these. So Cat 6 here just insulate another sort of plastic piece separating the 4 pairs. But 6A here, there's a tin foil that will actually seal the noises from each of the pairs. Okay, so generally, wider frequency band and better shielding will result in higher quality. So you see here, capacity better towards right, and the distance for the connectivity also longer towards right. Okay, now here's what the quiz 4 is asking. Given this sort of institutional network or home network, right? In the above enterprise network, what cable would you use for link 3? So where's link 3? Here. And link 3 is for this main switch to connect to a NAS, a file system server. And this is a file system server. Very often people access files, sometimes videos. So it uses a 10 gigabits per second Ethernet card. And it's definitely farther away from the switch, okay, in the company. So what cable would you use here? And more importantly, don't just tell me what cable. Hey, this is more important. Why? All right? Q2. What about link 6? Link 6 is over here. Oh, link 6 seems simple, but maybe some of you have different ideas connecting this 1 gigabits per second PC to the central switch. Okay? Think about, hey, if you would be using a cable, right? You need to kind of, stick the cable somewhere or to the wall. Not all the rooms have the Ethernet sockets conveniently for you to connect all the devices. All right? So what cable would you use for link 6? And you know what? Let's go to the score space. And yeah. Oh, I see some of you have already started working on it. So guys, you have 4 minutes. Gather your teammates, discuss, and leave yourself some time to pose your answer. All right, so let's start counting time.
Yeah, while some of you are still debating, it's okay because it's very likely that after some debate, you guys come up with different solutions. But let's check out what the students have already posted. So Ting Qi here actually posted cat 6A for, nice. Because it seems obvious, right? For link 3, in order for the NAS to be able to connect it to the rest of the institute, you just have to have something that goes high bandwidth and beyond 55 meters. And so 6A is the only option, isn't it? Very good. But it seems that, hey, for example, Yasin here is saying, to connect link 6, I'm going to just use 5E. It's the minimum option because it's definitely sufficient. And hey, as we always go with the cost-effective solution, this seems to be an obvious choice, right? And Tingqi here says, hey, okay. In fact, the condition is actually more relaxed in link 6's case. So, okay, of course. But if we really want to be thrifty, Cat 5 is the cheapest. 5E cheapest. Okay, so because we need capacity, very good. And I guess the first two answers actually gives the whole picture already, right? So I am not surprised that you guys will come up with something similar. 6A, 6E, the most cost-effective, exactly. I know, being students, what you think about it, we'll definitely be using 5E. Let's see. If people considers the cost of deploying these cables. So what if I'm gonna change the PC from 1 gigabits per second Ethernet card to 10 gigabits per second Ethernet card? Or replacing the PC with another server, right? Yeah, if we use 5E now, then next time we'll have to change it again. The cost of deploying that link 6 it includes also human labor. Is human labor expensive or not? It is actually more expensive than the cable itself. Yeah, definitely higher CP. Let me see. Okay. Consider the material cost, definitely. But guys, as I mentioned, if you be deploying something, you might as well going all the way up, because that way it saves you another trip, okay, changing it, in case the deployment of the device or the infrastructure itself is costly, not just the device, not just the material. All right, good. And that takes us back to the topic. And guys, you know what? It's already 2:09 and we are not have enough time to go over the next video. So come again tomorrow, 10:20. We're going to see the other cables, right? How about the cables for cable modem? How about the cables for the fiber to the home access net? And what about those unguided physical medias, the wireless cables? All right. And you know what? With that said, that's all for today. I'm going to see you tomorrow. And if you find that there's a few seconds left, why don't you guys try access the PA workstation and let us know so that you won't be too much in a hurry working on the PA one on Saturday. All right? So with that said, bye. See you tomorrow. Bye. And I think I failed to switch to the whiteboard mode. I was actually scribbling on the whiteboard. I'm not sure I did switch to the whiteboard mode or not. I might have stayed on the Q4 slide. Okay, bye. Tomorrow.